Well, good afternoon, everyone, and welcome to today's webinar. It's on the highlights from the 4th National Climate Assessment with Martha Shulski. I'm Tyler Williams. I'm an extension educator with the University of Nebraska located here in Lincoln. Today's webinar is being organized by the North Central Climate Collaborative, which we call NC3, which is an initiative of the North Central Regional Water Network. Before I formally introduce our speaker, I want to share just a couple things. Once we begin, I'll open up 2 polling questions, and I'll leave them up for a couple minutes to give you some time to respond. They're pretty simple, so I just would appreciate if you could answer those. I'll also do that at the end, so you'll have a couple minutes left, and you'll see a couple more poll questions pop up. So if you have a question along the way, go ahead and just type that into the chat box. I'll alert Martha if there's a pressing question to get it answered. If not, if it's just a general question, we'll have time for that at the end, and so we'll do some Q&A then. So I think that's all for me. So now I'm pleased to have Dr. Martha Shulski with us. She's a Nebraska State Climatologist and is an associate professor in the School of Natural Resources here at UNL. She was also a co-author on the 4th National Climate Assessment, which is the topic of today's webinar. So thanks, Martha, for being here, and I'm going to go ahead and turn it over to you.
All right, very good. Thank you very much, and thank you for the invitation to speak with you today. It's great to have so many participants here. What I'm going to be doing, as Tyler mentioned, is giving you highlights from the recently released Volume 2 of the 4th National Climate Assessment. And I just wanted to start off by giving just a little bit of history about these climate assessments. So I mentioned this is the 4th National Climate Assessment. So these assessments came about from the Global Change Research Act of 1990. And you can see the directive here to provide for development and coordination of a comprehensive and integrated U.S. research program, which will assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. So that's the directive passed back in 1990. So it is a federally mandated program, and there are 13 federal departments and agencies that are involved in this assessment. And if you'd like more information about the U.S. Global Change Research Program, the URL is listed there. So I invite you to go and visit that website. So it's been roughly every 4 years that this assessment has come out, give or take a few years. And what I'm going to be showing you today actually comes from both the Climate Science Special Report that was released in November of 2017. That is Volume 1 of the 4th National Climate Assessment. And that came out again November of last year. And it's really more kind of a scientific assessment of climate change. It looks at historical trends as well as future projections. And a lot of what the impacts are based on in this Volume 2 report comes from this Climate Science Special Report. So there's a lot of good information in this Volume 1. I'll show a few graphics from that, and then I'll try and show the highlights from the report that was released in November, just a few weeks ago, here in 2018. So Volume 2 encompasses impacts, risks, and adaptation in the U.S. And it's kind of a tall task, really. It's about 1,500 pages long. This was very much a collaborative effort. There was over 350 authors on Volume 2 alone. It was years in the making. I came on board for the Northern Great Plains chapter in 2016. It was very much a process. It went through internal and external reviews, lots of public comment. So certainly very much a process in the making. So, and the way these slides are outlined here in the upper left-hand box, that gives you kind of the chapter. So this is from the introduction chapter, and also it's in the upper right-hand corner. This is the kind of the overview chapter of NCA Volume 2. And clearly there's a lot of really good information in here. And what I've done is just kind of pull some highlights of when I give talks to the public or certain sectors. These are the key points that I think are really relevant and things that I really hit on, and things that are kind of stronger language than what it was in the NCA3, the 3rd National Climate Assessment back in 2014. So this is just to kind of set the stage. So I'll just kind of read through the bullet points here. Earth's climate is now changing faster than at any point in modern civilization. So it's the rate of change that is particularly concerning in recent past. These changes are primarily the result of human activities, and this report does a really nice job of looking at all the contributors to global temperature trends historically over the last century in particular, and looking at human activities as well as natural causes of climate change, and breaks it down, and you can clearly see that that human activities are primarily causing the issue that we're facing today. The impacts of climate change are already being felt across the country, so it's not something that is yet to be realized in the future. It's something that is happening here and now, and that's really something that I try and hit on with audiences around Nebraska and around the country. Is we can point to examples of how we're already being impacted. And America, in the US, we are responding, and the NCA report does a nice job at looking at adaptation efforts as well as mitigation efforts. So we are responding to this. However, there's a big however here: neither global efforts to mitigate the causes of climate change nor the regional effects to adapt to the impacts currently approach the scales needed to avoid substantial damages. So we're doing things to adapt as well as mitigate, but it's not nearly the scale at which we need to mitigate those severe impacts. All right, now I'm going to be showing some different scenarios, and the NCA4 it primarily uses this higher scenario, which is termed RCP 8.5, and RCP stands for Representative Concentration Pathways, and there's 4 different levels. There's 8.5, 6.0, 4.5, and 2.6, and those numbers basically correspond to what the greenhouse gas concentrations are going to look like in the future. What is our rate of increase of carbon dioxide, for example, and methane and other greenhouse gases? In terms of a climate model, these scenarios translate into a radiative forcing. That's how these temperature changes are realized. It's because of these differences in radiative forcing. So you increase greenhouse gas concentrations, you enhance this naturally occurring greenhouse effect, and the more you enhance it, the more radiative forcing you're going to get, the higher the temperatures are going to be. So if we look at, in this graphic, it shows you historical change going back to 1900. So in the dark gray curve here is observed global average temperature, and it's showing you 3 different scenarios. So the 2 I'll be showing in particular is this RCP 8.5, or we'll just call it the high scenario. And that assumes that there will be no behavior change. We will not, it will be a business as usual approach, and we will continue on the current path, essentially. And you can see that trajectory where it continues to go, the temperature change, global average continues to go up. The lower scenario, this 4.5, that assumes active mitigation. And essentially you can think of the CO2 concentration, for example, that we don't go much above 500 parts per million in the next century. Currently, we're at 400 parts per million. So that just gives you, something to compare it to here. So you can see at the end of the century, those differences in those 2 different scenarios. So this just kind of sets the stage in terms of what these projections and then the impacts based on these projections are based on. So those are the scenarios that's used. There's also regions, so there's a chapter for each region. So I was on the Northern Great Plains chapter in addition to 10 or 11 other authors. So the regions are outlined here in this map, and so you can find whatever state you're in or whatever region you work in and find a particular chapter that looks at what are the key issues of concern for these different regions. And one thing that has been an improvement over the last one, climate assessment, is dividing the Great Plains into the northern and southern halves, which was a good thing of giving more localized information. So in addition to these 10 regions, there's also 15 different sectors that you can also find a chapter at, and that includes agriculture and water, indigenous communities. There's a couple of new ones this time around, national security and complex systems. Those are our new sector chapters in this National Climate Assessment. All right, so I'll kind of continue to set the stage here. So I'm going to be showing temperature and precipitation projections. And so this one, the top here, we're looking at middle of this century. So that covers the period the average of 2036, 2065, so that 30-year average period. And we're going to be comparing lower scenario with higher scenario. And you can find the area that you work in, and so the scale is down here. So in the kind of the north central region, anywhere between 3 and 4 degrees Fahrenheit warming compared to what it has been over this most recent 30-year period. And if we go to late 20th century, you can see how the lower scenario and the higher scenario really start to diverge, where if we actively mitigate greenhouse gas concentrations, then we're looking at still a 4 to 5 degree temperature increase for kind of the north central US, or up to 8 degrees Fahrenheit for this higher scenario, business as usual scenario. So one thing to point out here is if we compare this trend over the 21st century to the 20th century, the rate of change is quite different. So in the US, we've warmed about 1.5 degrees or so over the last 100 years. So the rate of warming going forward is much faster than what it had been historically. So something that will certainly be very impactful if we get into extreme events. And what I'm showing here is high temperature and low temperature extremes. And so the graphic that you see here, so we're looking at the high scenario. So by the middle of the 21st century, we're looking kind of in this part of the US, 20 to 40 more days where the high temperature goes above 90 degrees. If you are interested in different metrics, if maybe 90 is not too severe, say if you're in Kansas, maybe you want to look at 95 or 100 or 105. That's those model projections are available from the National Climate Assessment. So I'm just showing the 90 degree threshold here, but there's a lot of temperature threshold projections that are available. So if this doesn't suit your needs, then there might be others that you can find online. But so compared to what the most recent 30-year averages are, this is the projected increase in days with high temperature above 90 degrees, 20 to 40 more days by middle of the century using this high scenario. So if we look on the flip side, I mean, one message that's pretty clear is more hot days and much fewer cold days. So here we're looking at a number of days that the minimum temperature goes below freezing. And again, there are other metrics. You can look at days the minimum temperature goes below 0 and other thresholds as well. But if we look at a 32 degree threshold, then again, for this region, we're looking at 20 to 40 fewer days where the low temperature goes below 32 degrees. So warming overall, the amount of warming dependent on these different emissions scenarios, kind of depending on the path that we take. And if you look at those extreme events, kind of the tails of the distribution, we're going to have more hot days, much fewer cold days. So we'll look at precipitation next. And in a general sense, and something that I tell my class, I teach an undergraduate course on climate change, and kind of a message, consistent theme in the precipitation projections is that the wet areas will get wetter and the dry areas will get drier. And what we're looking at here, so this is end of century, and this is using the high scenario. So for winter and spring, which is shown at the top here, we're looking at anywhere from 10 to 20 or greater precipitation. So kind of in the colder time of year, as well as spring. And spring, for this part of the country, that's where we have historically seen an increase in precipitation. Certainly the north central US, we've seen wetter springs and more days with precipitation. So that is projected to continue. And yeah, I should have pointed out here on the left of the slide, kind of gives you information about it and where it's from, if it's from a journal article or so forth. So you can read that information if that's of interest to you. The red dots that you see are where projected changes are large compared to natural variations. And the areas in hatches are kind of where you have a very low signal to noise ratio, meaning that the projected trend is not as small and relatively insignificant when compared to the variability. So I'll add the other two seasons here. So you're looking at summer and fall. You can see in fall, a lot of the areas of the US are hatched. So the projected changes are not large compared to kind of the natural variability. In summer, portions of the region are projected to get drier. Here in Nebraska, portions of the Dakotas, Wyoming, and Montana, we're looking at least a 5% change in summer precipitation. We combine that with warmer temperatures, certainly have more evaporative demand, more crop water use, and so forth. You can start to look at impacts particularly when you couple temperature and precipitation changes. Okay, so similar as what we did with temperature, we'll look at heavy precipitation events. And again, for the Midwestern US and particularly in the Northeast, we've seen historically an increase in those heavy precipitation events. This is looking, again, we're comparing the lower scenario and the higher scenario. Projected change in total annual precipitation that falls, that occurs in the heaviest 1% of events. This is looking at end of the century. You can see a lot of the US is in those green and blue colors. So a 10 to 20% increase across the region in the amount of precipitation that falls in those heaviest 1%, highest 1% of events. And then if you look at the high scenario, we're looking at 10 to even 40% or higher increase. So that's another really consistent theme that came through in this National Climate Assessment is the occurrence of extreme events in terms of precipitation and leading to significant impacts in agriculture, for cities, and so forth. So more heavier precipitation. Okay, well, I apologize in advance. There's a lot of information on this slide. What I'm getting into now is what I've done is kind of set up temperature and precipitation projections for the US as a whole. And so now we'll kind of dive into I'll talk about a few kind of central themes from the Northern Great Plains and talk about a little bit from the Midwest region. And so one thing that we did with the Northern Great Plains chapter, which I'm not sure all chapters went this route, was to kind of look at our region and call out specific examples of responses, things that are being done in response to adapting to climate change or mitigating future climate change. And a thing that is very important for the Northern Great Plains region, and for those of you coming from this region, certainly not to probably telling you something new, but there's a lot of year-to-year interannual variability, both in temperature and precipitation. And there's a very strong gradient, moisture gradient, humidity and precipitation gradient from east to west. For example, here in Nebraska, we get twice the amount of precipitation on the eastern side as we do in the west. So we transition from kind of the humid continental of the eastern US to this arid zone and intermountainous zone in the west. So there's a lot of variance and variability in the Northern Great Plains region. And So these pictures here, again, they're just showing, kind of calling out examples of how people are responding to climate variability and climate change. And I'm going to, in particular, talk about something that I'm more familiar with, being from Nebraska. And if we look at just kind of the Platte River Basin here, and we'll focus on this number 8 point here. And this brings up, I think, a really interesting point, and something that I've heard other National Climate Assessment authors talk about and social scientists talk about, and that's really improving and strengthening the dialogue when it comes to climate variability and climate change. And this example is the Platte Basin Time-Lapse Project, which began, I believe, in 2011. And what they've done is place cameras throughout the Platte River Basin, kind of in Colorado and in Nebraska. And they incorporate storytelling, and they look at this watershed in motion and tell the story of where we get our water. You know, in Nebraska, groundwater is very important, as well as surface water, and where it starts in the Rockies to where in the Platte it goes into the Missouri River. And so it's a really nice example of how you can use visuals and tell the story and start or continue the dialogue and increase awareness of climate issues. So for each chapter, there are key messages. And the way we did this as an author team, so we have a lead author for each chapter, and there's about 10 or so contributing authors that kind of help the lead author. And we kind of self-identified there was much discussion on identifying these different themes, so water, agriculture, recreation and tourism, energy, and indigenous communities. So these are kind of the 5 important themes that are significantly impacted from climate change and climate variability. And so several authors kind of worked on specific themes. So for both the Northern Great Plains and the Midwest, what I'm going to do is have a slide about a few of these, and we'll kind of go through them. And what I've done, the key messages are a little bit lengthy, so what I've tried to do simplify them here. Water is the lifeblood of many areas, but particularly the Northern Great Plains, and effective management of those water resources is critical going forward. Small changes can have big and significant impacts, making management a challenge. And future changes in climate increase variability, increase extreme events, increase temperature, and changes in precipitation patterns. Those are very likely to exacerbate these challenges that we inherently have. And so there, in the Northern Great Plains chapter, we looked at snowpack and the importance of springtime snow melt runoff from the Rockies. And one thing that stood out to me is the fact that we have reservoirs and groundwater in this area, and those are expected to be increasingly important as buffers against the impact of increasing variability and to meet water demands during periods of shortage, especially in light of warming-driven losses in snowpack water, higher evapotranspiration rates, which will ultimately reduce the total amount of water variability. So it's calling out the importance of these buffers that we have in the system to mitigate against this variability, the increasing variability that we're going to be experiencing. Agriculture, a very critical component to livelihoods in the Northern Great Plains. Rising temperatures and changes in extreme weather events are very likely to have negative impacts in parts of the region. And I thought this was important to highlight here. Adaptation will likely require transformative changes in management, including regional shifts of agricultural practices and enterprise. And I think about the rates of change that are projected in temperature and precipitation, and they're unlike changes that we've seen in the past. It's going to be happening at a much stronger rate. And agriculture has historically been quite good at adapting. Maybe some of the best adaptations take place in the agriculture community because they are so dependent on weather. But what we've done in the past will likely not carry us through to these extreme changes that we might be seeing here in the future. The chapter also does a nice job at calling out some specific impacts. So these are taken directly from the chapter. So warmer, generally wetter, particularly in the winter and spring, and elevated CO2. So here are just some impacts that we'll likely see. Increased soil water availability in the north because of the increased precipitation, but decrease in the south. Increased precipitation won't offset the increased water evapotranspiration rates in the south. Increase of extreme high temperatures during pollination and grain fill, ultimately reducing crop yields. Increasing abundance of weeds and invasive species in a range of crop pests. Alteration of plant phenology, including earlier onset of spring, and decreased quality of forage. Another key message was related to energy. Fossil fuel and renewable energy production is expanding. Climate change puts this infrastructure of supply of energy at risk. The energy sector is also a significant source of gases that contribute to climate change as well as ground level ozone pollution. So in North Dakota specifically, there's been a boom in fossil fuel energy production. But on the flip side, there's also wind is a very important renewable resource that is being developed throughout this region. One thing that was called out in the chapter, and this really holds true throughout the US, is the infrastructure that supports energy vulnerable to the impacts of climate change. This is an example from 2011. This is Fort Calhoun nuclear station, which is just near the Omaha area. So it's on the Missouri River. It was actually decommissioned in April of 2011 prior to the start of the flood, but it had to be completely shut down because of potential risk that the floodwaters posed. And I believe in 2016 it is taken completely offline and no longer in operation. Indigenous peoples, so that was another key message. Indigenous peoples throughout the country are at high risk from a variety of climate change impacts. These changes are already resulting in harmful impacts to tribal economies, livelihoods, sacred waters and plants used for ceremonies, medicine, and subsistence. However, many tribes have been very proactive in adaptation and strategic climate change planning. There's a lot of great examples from tribal communities. Personally, I've worked with the Wind River Indian Reservation there in central Wyoming. There's a lot of great work being done on Pine Ridge, Rosebud. I've worked with some of the Nebraska tribes. There's a lot of, those are just a few examples. There's a lot of great work that's being done in Indian country. Okay, so we'll switch to the east here and look at the Midwest. There were 6 themes. These cover agriculture, forestry, biodiversity and ecosystems, human health, transportation and infrastructure, and finally community vulnerability and adaptation. So these are again, the kind of the central issues and impacts to these sectors that the authors found were particularly important to call out here in this National Climate Assessment. And again, so the region that the Midwest covered is in this small map here up on the upper right-hand side of the slide. And this is chapter 21, by the way, in the Climate Assessment Report. So I already say for the Northern Great Plains, I already talked about impacts to agriculture. They're quite similar for the Midwest. The increasing extreme precipitation events are certainly a concern. That's something that producers are already dealing with, and wet during the spring. So this excess of moisture, excess of precipitation, what it's doing to the fields, potential for erosion, getting equipment into the field when you need. These are all things that are already being dealt with, and certainly something that's projected to continue and at even a higher rate. So an example that's called out in the Midwest chapter is conservation practices, reducing the impact of heavy rain. So here we're integrating strips of native prairie vegetation into row crops, been shown to reduce sediment and nutrient loss from fields, as well as improve biodiversity and delivery of ecosystem services. So this one came from Iowa State University. It calls out their program to look at this agricultural conservation practice. I also wanted to mention, I noticed there were some people that had signed up for the webinar that were interested in forestry applications. Midwest forests provide numerous benefits, yet threats are interacting with existing stressors to increase tree mortality and reduce forest productivity. Without adaptive actions, these will result in loss of economically and culturally important species. Sorry about that. There we go, okay. Land managers are beginning to manage risk in forests by increasing diversity and selecting for tree species adapted to a range of projected conditions. An example that is given here, forest diversity can increase resilience to climate change. This image is from the Menominee Tribal Enterprises, which I believe is from Wisconsin, the Menominee Nation. They're creating opportunity from diversity by replanting a forest opening caused by oak wilt disease with a diverse array of tree and understory plant species. So kind of the message here is increasing diversity will ultimately help your conservation practices and reduce risk. Okay. Another thing that is called out here, a key message from the Midwestern portion of the US is human health. Climate change is expected to worsen existing health conditions and introduce new health threats. This is from poor air quality, extreme heat and heavy rainfalls, extending pollen seasons, and modifying the distribution of disease-carrying pests and insects. So a lot of factors here that are kind of combining to worsen these both existing conditions and introduce new health threats. By the middle of the century, the region is projected to experience substantial yet avoidable, which I think is important to point out, loss of life, worsened health conditions, and economic impacts estimated in the billions of dollars as a result of these changes. But it does give kind of solutions here. Improving basic health services and increased public health can prevent or reduce these impacts. And I'm going to show an example here. This is from the city of Chicago. So the annual number of days, the city of Chicago reports a high temperature above 100 degrees. If you look in the recent past, this black dot here, it's essentially zero, which means every few years they might get one or a few days. It doesn't mean they've had no days above 100, but it means that it's not very common. Therefore, people likely don't have the resources to cope with or to deal with these high temperatures. But if we look going forward, kind of in the middle or near term, middle of the century and end of the century, this is showing, again, the lower scenario and the higher scenario, and a really marked increase in these number of extreme warm days. And if we think about kind of the infrastructure that's in place, it's certainly would not be enough to handle these types of medical issues that are coming in. Cooling shelters, providing fans, looking at households that don't have air conditioning, do they have access to, do they have the ability to cool down? If the nighttime temperature also does not cool down, below, say, 80, 75 degrees or so, then that's going to even worsen the situation. So extreme heat would certainly be one health-related impact here. Okay, so what I hope that provided, again, was just to kind of give you a broad overview of what some of these regional chapters are saying. And again, for any region in the country, you can go on and kind of read these key messages, look at kind of these examples of how we're responding to climate change. There's a lot of good information in these regional as well as sectoral chapters. So moving forward, what do we do about it? If we look at reducing the risks of climate change, so here what I'm doing is pulling from I believe it's chapter 1 here, the overview chapter. Many impacts can be substantially reduced through global scale reductions in greenhouse gas emissions, complemented by regional and local adaptation efforts. Okay, so it's going to take kind of this multi-pronged approach where clearly these greenhouse gases, it doesn't matter, in the end, it doesn't matter where they're emitted because everybody is impacted by them. But that's where you're going to make the biggest difference in terms of mitigation at a global scale. But this also needs to be complemented by regional and local adaptation efforts. Since the third National Climate Assessment, which came out in 2014, a growing number of states, cities, and businesses have pursued or expanded upon initiatives aimed at reducing greenhouse gas emissions, and the scale of adaptation implementation across the country has increased. So that's a very good thing that we have these initiatives that are stepping up in a period of several years. We've had cities, states, and businesses look at reductions in greenhouse gas emissions, look at scales of adaptation at the different levels. So it's a good change that we've seen over time. There is a however, these efforts do not yet approach the scale needed to avoid substantial damages to the economy, environment, and human health expected over the coming decades. And for the greenhouse gases, if you think about CO2, that's something that lasts a century. And so emissions that are, this gas that's emitted in 2018, that's going to be around for generations to come. And so the sooner we do something about it, then the better. Our risk is reduced. So in terms of mitigation-related activities, there's a mention here in the overview chapter. If we look kind of state by state, so we look at total number of state-level mitigation-related activities. So you can see where more activities is taking place as opposed to less activities. And it also looks at cities supporting emissions reductions. Here's a total of 455 that have active and implemented programs in place to support emissions reduction. So things are happening at the city level, at the municipal level, and at the state level. And then finally here, again, we're kind of comparing here where we were 4 years ago to where we are now. And if we think about adaptation and looking at it from kind of a risk management perspective and trying to reduce those vulnerabilities, just in a very general sense, one step is becoming aware of the issue. So pictured here would be a flood event. And from awareness, then you go to assessment, taking observations, looking at things that are going to be taking place in the future, and how can let's assess the current state of the situation. And then we go towards planning. How can we plan and better be prepared in the future, reduce our risk, assess our vulnerabilities, those kinds of things. And this could be directed toward anything. It could be a drought plan. It could be some sort of plan for your farm. It could be planning at the municipal level and incorporating climate change projections into that planning effort. A plan is great, but then you need to implement it. Otherwise, it doesn't do any good. So implementation of the plan, and then monitoring and evaluation. How effective was it? How, did it work? What improvements do we need to be made? And I've heard, I have some colleagues from the National Drought Mitigation Center, and it's something that they say, a lot of things they say stick with me, and one of them is that planning is a living process. And if your plan is 20 years old, if you're a city, then likely things have changed in 20 years. And so plans constantly need to be revisited and revised, and it should be considered a living, breathing thing, and not just something that is done once and then you forget about it. So it's looking at kind of where we were overall in the US in a very general sense in 2014 compared to where we are now. So progress is being made, but at this point it's not at the scale that we really need it to be. So just a couple of parting thoughts, and I apologize if I didn't touch on your particular sector. There's a lot of information in here, and so trying to describe it in 40 minutes is a little bit difficult, so I apologize if I glossed over something that you're interested in particular. So these are some of my takeaways, so I won't attribute these to the National Climate Assessment. It's just kind of my paraphrasing and what I would say to my class, for example, or what I would say to a group of farmers that I'm giving a talk to on this topic. Is it's important for people to think about, climate change is something that is already here. It's not something in the future. It's not something that impacts Alaskan villages on the coast only. Certainly it's impacting them, but it's already here. And when you think about it, we are the cause of it. It's clearly shown and to be the case if you look at some of these graphics that are shown in this, we know that we're the cause, but we're also the solutions. That's a really critical thing to think about. The sooner we act, the less risky it is. And, I get asked, what's the threshold? What's the point of no return? And you can't really put your finger on a specific year that we have to solve this by. It's kind of a moving thing, and it will just continue to get worse. The sooner we act, the less risky it is. And there are a lot of great examples that are called out in this National Climate Assessment. And so if you're coming from a particular sector and you don't necessarily have a solution or have a path forward, well, there might be something from another aspect within your region or within another sector that are kind of lessons learned and might be good to follow in whatever your sector is. Okay. And then finally, my last slide here. So the National Climate Assessment, while it's a large comprehensive document, it's not meant to be all-inclusive of impacts, but serves as an excellent starting point. So personally, that's how I view this. As a state climatologist, I get asked a lot about climate change and impacts for Nebraska, and this is a great place that you can start. You can look at all of these model projections of days above 95, days below 0 degrees, changes in growing season length, changes in heating degree days, all these different metrics that we have climate projections for. It's a really great starting point. Another thing that I think about and have learned actually in talking to different groups is that all climate impacts are local. we think about and talk about global temperature increase and global rise in temperatures, but at the end of the day, we live locally. So, tying it and connecting the dots to your local community is really, really important. Therefore, know your local or regional climatologist. There are a lot of climate folks, and Tyler Williams, who introduced me, he's my colleague, and he's one of them in the extension community. So whether it's with the extension service, with a state climate office, a regional climate center, with a USDA climate hub, with a NOAA regional science center, there's a lot of good resources that are out there, and so reach out to us. And then finally, the best thing we can do going forward, in my opinion, is work together and start or continue the dialogue. If we don't establish or keep and establish and strengthen a dialogue, then we're just not really going to get anywhere. So that's a really important thing we can do. That is a critical part of the solution, in my opinion. So that's what I have for you today. What I've done is included here, so there's the website for the National Climate Assessment. There's the citation from the Northern Great Plains chapter. You can get, again, each chapter and each sector will have a citation. And again, this was a, the very definition of a collaborative effort with lots of input and lots of voices here that are being represented. So Tyler, should I kick it back over to you, or?
Sure, yeah, thank you. There's a few questions in the chat box, so I'll just, I don't know how easy it is for you to open it and look at it, so I'll just read them to you. First one is, there are 52 mentions in the report of methane, yet there's only one instance where it is tied to ruminants. Could you comment on whether that is because other sources are more important, or did the report steer away from cattle production?
Okay, so my sense would be that kind of a significant kind of unknown really in climate change, and when it comes to methane, is all of the methane that's locked up in permafrost, so permanently frozen soil, and under the seabed in the Arctic. There's a really large amount of methane that is currently frozen, and the Arctic is warming much faster than the rest of the world. I think twice as fast as the global average. So the real concern, as I understand it, in terms of methane at a very large scale, is the potential for large amounts of methane to be released that is currently kind of stable and locked up. And so once that does get released, methane is a very potent greenhouse gas. It doesn't have a very high concentration, but it is radiatively very, very important. So that would be my my guess.
Okay, thanks. Next one, how do the NCA4 adverse impacts compare with those identified in the IPCC 1.5 degree report?
Okay, yes, I'm seeing that. And what level of emissions reduction is needed?
Oh yeah, that was the second part too.
So, yes, so IPCC, so the NCA4 uses the CMIP5 projections. And the NCA is a national look, whereas the IPCC is kind of this international look. And so, so kind of the focus is certainly different. And so the IPCC 1.5 degree, I'm guessing that's like a 1.5 degree C rise in temperature, but I'm not quite sure here. Yeah, I guess if I haven't looked at those, side by side necessarily. What I'm more familiar with is kind of the evolution of the NCA, like from 3 to 4, for example. And I'm a bit less familiar with the NCA when compared to the IPCC. But certainly there are efforts to utilize, climate model projections that are, of the same generation and of the same scale.
and Martha, there is a question just a couple down on differences from NCA 4 to NCA 3, if you'd want to make a couple comments on that.
Yeah, so yeah, and what each National Climate Assessment does is we go through an extensive look at the literature. So it incorporates, what is the latest information, the latest and greatest, so to speak. What's the new knowledge that has come out? And we were asked to actually not start with NCA 3. Look at it kind of as a standalone. Look at the current, recently released literature. In my opinion, so NCA 4 dives a bit deeper in terms of examples at the local and regional level. It goes into greater regional detail. For example, breaking up the Great Plains into northern and southern was a great idea. And so a lot of these improvements are based on feedback that's received. The language, I think, is stronger. In my opinion, kind of the confidence in the results and in the impacts are stronger in NCA 4 when compared to NCA 3. So kind of in general, those are my takeaways.
Okay. I know you saw the question, but I'm not sure if you touched on it, the one about what level of emissions reduction is needed to avoid the worst impacts.
Yeah. Well, so I showed the 8.5 and the 4.5. Those are kind of the high emissions and low emissions scenario. There's also an even lower one, which is the 2.6. And I kind of think about CO2 is not the only greenhouse gas, but I tend to kind of use that as an example. We've got great historical observations of that. And, we're at about 400 parts per million globally. And the 4.5 scenario, the lower scenario, that assumes that by the end of the century, we're going to be at about, I think, 500 or so parts per million. There's an even lower one, this 2.6, and that gets us kind of down below where we are now. So those are the two, and the 4.5, that keeps us within line of, say, the Paris Climate Agreement, which is below global average temperature not rising above 2 degrees Celsius, or about 4 degrees Fahrenheit. So that's kind of where the international community is now in terms of where we need to be. If you compare that to the 8.5, say CO2 emissions, that's, I think, up around 1290 or so. So that as compared to 400, what we are now. So that just gives you kind of the range.
Okay, and you sort of just answered it, but I'll ask it. Do we need to completely decarbonize to avoid the worst impacts?
Well, so in the NTA report, I believe it's in the overview chapter, it does a nice job at looking at greenhouse gas emissions by, coal and oil and gas. What are the big contributors to greenhouse gas emissions? Coal's definitely one of the bigger ones, and that's, I think recently that's kind of reducing or not necessarily phasing out, but that's getting smaller. But yeah, that does a nice job of looking at where can we make the biggest impact in terms of emissions. What source of energy is kind of the highest contributor. So I would encourage you to kind of look at that graphic. But it's, fossil fuels, certainly that's the huge contributor.
Okay, another question of where is a good source for examples of solutions?
Yes. Great question. I'm trying to think of one go-to source. That would be one where I would say, get in touch with your local climatologist. There's so much information that's available. Solutions are mentioned. They're not covered extensively in the NCA report, but that would be a good starting point, would be to look at there's adaptation and mitigation chapters, 2 different chapters would be great starting points, and kind of look at the key messages. And solutions, it's kind of somewhat dependent on are you looking for personal solutions or kind of for a particular sector. So it can be somewhat dependent on on kind of what you're thinking about, whether it's policy solutions or local solutions. But that's where I would say use your local resources. Get to know your state climatologist if you haven't already, or your extension climatologist. But yeah, I would say the adaptation and mitigation chapters of the National Climate Assessment would be a good place to start from.
Okay, one more here, a little bit longer, but one of the key messages was how reservoirs will help ameliorate the impacts of climate change. Constructing reservoirs typically has other severe impacts on ecosystems. How do you reconcile these two issues? And is the report implying constructing more reservoirs, or is it saying those currently constructed will help, but is not advocating for building more?
Yes, so the strategy is to things that are already in place, that those are going to be even more important in the future. So it's not necessarily advocating for we should build more reservoirs. We should, we shouldn't necessarily invest in that kind of infrastructure per se, but the ones that are existing and are managed currently, those are they're important now, I'm sure, because they were built for a reason, but they're going to become even more important as buffers in the future. So that's from the Northern Great Plains chapter anyway. That's kind of what that aspect was referring to.
Okay, I think that's the last question I see. I hope I didn't miss anything along the way there, but I think we've got them all. So they have your contact information, or they can Google you and find you. So they do have questions. You can reach out to me or Martha. But Martha, I do appreciate you taking time to share with us. It's quite a lot to share. I don't know how many hundreds of pages in a report in 45 minutes. So I appreciate you doing that for us. And for everyone else, thanks for joining this month. We'll be back again in a couple months with the next webinar. So thanks again for joining. Have a happy holidays.